So continuing the discourse, so if you have real-time data, as explained before, you have in any case some static information, such as the IoT broker of the device structure, on which that they have to be registered in advance with respect to the real-time stream of data. So the static information have to be registered in advance through the IoT directory, and those information is going to go in terms of triples into the knowledge base. While the information regarding the dynamic data are connected directly by using the Node-RED or IoT brokers directly to ingest this data autonomously. So it is very clear mechanism that will be better clarified later. Sorry. Okay, so this will be much more clear in the next sections that we are going to present. So the data are going to arrive directly in the Orion brokers. What has to be registered in the Orion broker is the data that could be collected from other protocols. So if you have some data that could arrive directly on the Orion broker, it would be enough to register the static part, because the real-time part are going to go inside automatically. So this means that the Node-RED part is playing the role of adapter for the Orion broker. On the flow diagram, we explained how can be addressed this part. GIS information is ingested typically via IoT Hub or WFS API or WMS APIs directly from the dashboard, for instance. And also social media can be ingested by IoT app or either ATL process. The ATL is still marked in yellow because they are going to be not used and presented here. But if you have interest in learning how you can develop a ATL process, because you are still compliant with the ATL, you can go and access to the course of the 2019, in which the detail regarding the ATL based process for data ingestion are described. So each of those major tools can be monitored and can be controlled in terms of data ingested, so you can see what is going on in your ingestion process using the data inspector, the service map API and knowledge base, and the IoT discovery enforced in the IoT hub. You may have also access to the Kibana. This is the Kibana tool, and the service map is this one, and the inspector is this one. So it is possible with these main tools to analyze and see the process of ingestion, at which point has been arrived, if the data are arrived in the knowledge base or in the data shadow. You can check if everything has been done in the correct manner. If it's not, you have in this map a clear evidence which are the process that bring the data in the different parts. In this workflow, it is highlighted also which is a special process for the graph setup, for loading the OpenStreetMap in the knowledge base, that you do once or every time that you would like to update the OpenStreetMap in the knowledge base. And you can use a number of IoT apps, this one and this one, for managing the ingestion. This app, this first app is the one that I am marking with this arrow, is available and ready, so you can use it. This app you can install, you can adapt according to your needs. You can generate tripods and loads, or you can even totally automate this mechanism if you are an administrator or if you use on-premise. The other app that we have here, so not the one, but the app number 2, is an app that you can develop or you can customize, starting from our apps as an adapter to ingest the data into the Orion brokers. So you need only to do it if the protocol is not connecting the device directly to Orion broker, but is some other device that are going to be connected. Okay. Data inspectors versus data process details. It is possible to access to the data inspector all the data that you have ingested in your organization are visible for you into the data inspector. The data inspector classifies the data according to high level, nature, subnature, value type, value name, data type, unit, as explained before. So you can play with the data. You can select a single line and see how the pin is located, and to see which kind of graphics you can use. So the data inspector present a cross filtering, so you can filter the data, and you can even click in on the pin to see the single pop-up in which the data are reported. And so if the data that you selected are real-time data, you can see the trend in the single trend below. So to see the trend with a view of 4 hours, 12 hours, 1 day, 1 week, 30 days, 1 year, and so on, depending on what you select. So you can even block the map, you can zoom, you can perform a zoom, or you can fix a map and filter on the basis of the map, or you can filter on the basis of the features of your data type. So there are a number of advanced features of the data inspector that are accessible only for root administrators and on-premise. So if you install on-premise, you can access to them. We are going in the next months to give the access to a wider kind of user, but presently these features is only accessible for administrators. A part of these features can be activated also for tool admin, for typically one person for each organization. So, but you have to ask. So, what is this feature? If you click on the healthiness micro buttons that present a color on the basis of the healthiness level of the single value, a pop-up is going to appear in which you can see the details about your process, so links to the service maps or links to all these features. So you see there GPS coordinates, high level, so the same, more or less the same information that you see in the wizard, but arranged with a different manner. What is in addition are the possibilities to link, to jump, and the possibilities to observe the correlated values. If you click in a sensor and the sensor belongs to a set of other sensors attached to a device, you can see all of them, and you can jump you can view for each of them a trend representing how is the healthiness, where is the healthiness of the system found some problems, and you can move these windows back and forward and zoom to see the healthiness. You can even mark, if you are a root administrator, you can even mark some of those dots representing the single measure. You can mark which, if some of them have experienced some problem. When you mark, the marking of problems is used by the machine learning approach, machine learning tools for estimating healthiness, to learn how to understand what is your opinion in detecting the healthiness of your kind of data. So this is very important because it is very relevant for us to understand when you think that a given sensor experiences a problem. So you may detect, for instance, that some sensor could be typically considered healthy, but according to your feeling, it's not. And so if you mark, if you let us understand, if you let us if you training, if you mark, we are going to train in the back office the machine learning algorithm to arrange a different sensitiveness of healthiness in this specific case of that kind of sensors. So it is also possible to access to the process details. Process means the details about how the data has been ingested. So the data could be ingested by using dishes, or in the case of ATL, or you can have some IoT info regarding the app. This part is still under addition. In the present version is still beta testing, is not available directly. So you have also the possibilities to upload an image, for instance, to show the sensor, how the sensor device, how it looks like. If you have installed the sensor, maybe in a trees, or you in some pillar in the middle of the city, it could be very useful to understand which kind of look and feel should have may have your device installed. So the last folder is reporting the ownership. So details about who is the owner, which is the license, which is the address, and which is the email at which you should refer if something's get wrong. It is very relevant to have it. So this is an example of all the view. You have this kind of information not only for sensors but also for external services. You may have different kind of views according to different high-level type. So if you have a high-level type that has no sense for that high-level type to have a process, the process will be missing. And so you are going to have only the information related to the high-level type. Okay. So every time that you ingest something and you have already pushed the data inside the Elasticsearch, these data are indexed in the Elasticsearch, and you are going to have this couple of tools that are called DevDash and AMMA. The DevDash is a tool synergic with the data inspector that could allow you to perform a segmentation and filtering of the whole data entered in the platform. So you can make an analysis of the amount of data for each data stream, for each device, to see if there is a healthiness or not. If you can see, you can filter by geographic position, you can filter for value type, for value unit, for data type, for nature, for subnetworks, or you can really filter for user if you have a specific user that has created some problem. So you can really make a segmentation and analysis of the whole set of data flow inside. In terms of data is a dev dash. In terms of messages and volume is the HAMA tool. This is the dev dash. There is a video now that show you how it's possible to manipulate this kind of tools. So you can click in all of this and selecting data type, kind, and device name. You can search for a device name and select. You can identify the ID. You can really filter and focus on what you would like to have. In terms of time, you can filter a segment, a temporal segment in the flow timeline reported above. You can filter and segment some of those segments and combination of value type, data type, and so on. You can even filter on the map. You can select a part of the map, or you can select the organization as you have here on the right side. Now the demo is selecting the PI piece regarding the Helsinki, and all the data are going to focus only on the Helsinki side. So I asked for the focus, and I am zooming on Helsinki. and zooming. I am observing now that the dots represent the amount of devices and messages addressed in that period for that part, and these are the trends, the value trends, the accumulated, and so I have details in the table below. I can see the single message, and I can see the relationship and the value type distribution and the distribution of in over time. Okay. So as a first step for data ingestion, the first step is to load the road graph on the knowledge base. This means that from one side we need to connect to OpenStreetMap to extract the information and to upload this information in the knowledge base. There is a tool, a special tool that allow to do that. This tool is available in the open source, and you can use it. You can ask it for a virtual machine to do this kind of job, or you can find directly in the virtual machine for the knowledge base that service available. So you can use that service as a tool into the knowledge base. So you just put the data regarding the OpenStreetMap and loading into the knowledge base. There is a technical note describing that activity, so you can really do and follow the instruction to do it. You can use the service map. The service map tool is available on the left side of the portal, and you have a knowledge base, so it's possible to access to the knowledge base. There is a knowledge base typically for each organization, and you can access from the left side. You see they are marked in yellow with the yellow icons, and you see your knowledge base. Sometimes are multiple, because there are some organizations that may have multiple views or multiple areas or topic areas, and it's not only focused on only one knowledge base. They may have access to multiple. And for each pin that you see on the map, you can make a query, and you can click and see the data associated with that pin. If it is a point of interest, you get only static data. But if, as in this case, is a sensor, you can get real-time data. You can even jump from the service map to the log disit.org. It is a tool for browsing inside the knowledge base. So even this tool is open source, is also fitting inside the knowledge base virtual machine, so it's possible service map, and so are a couple of different tools. The first one to see the map and navigate in the map and making query and semantic query by click and selecting the different kind of nature and subnature topics and identify the area, as you can see here in this picture. And you can select even special shapes on which you can look. You can search in a special shape, or you can search along a path. You can really test almost everything from the service map, including the routing algorithm, multimodal routing, and the text search, and most of the APIs, the Smart City APIs, can be tested by using the service map. This will be better explained in the section 7 of this course. So when you jump in the linked open graph, disit.org, it is possible to access and perform a semantic query in the knowledge base. The knowledge base is accessible as a linked open data, so you can make a semantic query, but you can also access to the single linked data when you need. So the knowledge base is based on CKAN4City ontology. CKAN4City ontology is a multi-domain ontology, including geospatial reasoning, temporal reasoning, relationship reasoning, including metadata, statistics, research resilience, licensing, open and private data, and so on. Is an ontology modeling mobility and transport, sensor, energy, health, so multiple domains. So according to Berners-Lee, so we have the five-star approach of the linked open data. We think that the approach of CKAN4City is much more, is beyond the linked open data, because it provides not only linked open data or with the capability of browsing the linked open data or query the linked open data, but also reasoning on linked open data. So we think that we can call six stars model. This is an example of the ontology. The ontology is also license-free. It is license-free and is also based on other vocabularies and standards that are also license-free. So this means that the ontology can be freely used without any pay any license at any level. So you can start the knowledge base by starting from an empty knowledge base. You can initialize the road graph with according to the municipality. You can use OpenStreetMap. To do that, we suggest you to see the notes on web page 397, and it's explain how to use it. This tool that is called the OpenStreetMap to CKAN4City is included in the knowledge base SM virtual machine and Docker. So you don't need to have to install an additional tool. You can use the tool inside the Docker and virtual machine. If you would like anyway to have it, you can download it from the GitHub, and you can to give you an idea of what is going on, how heavy it is to have a road graph installed inside. In an area of 1 million of inhabitants, you can load this, you can initialize your system in few hours. Okay. At the present, the Snap4City has a knowledge base set up for a number of regions. You can see the list of them represented in this graph. You see a lot of them. So Finland, north of Italy, center of Italy, Sardinia, south of France, some parts in Spain, Croatia, and Greece, and also in Belgium. There are some other smaller instances in the hands of industry and other cities around the world, but are not connected with the general super index that we have. We have this super index as a federated service map that you can join if you like. If you install the knowledge base on your premise, you can join the federated service map and put in connection your service map with the other service map around the world. Please contact us if you like. Or you can create your separate federated network of service map, exploiting what we call a super service map. So the super service map is a layer that allows you to connect the different service map of different areas. Very easy. And if you have a mobile app that is going to connect not directly with the Smart City APIs, but through the super service map, this means that your app moving from one area to another will continue to work, maybe passing another services. And if the other service is going to be protected because the content is going to be licensed, the license will be requested automatically. So you can preserve your data. Even if you have a private data and you would like to join the federated network, you can do it, no problems. The system is going to respect your privacy and your, let's say, ownership of your data. CKAN4City is the reference ontology for Snap4City, and this is a live tool, so we are continuously improving. You can keep connect entities by using this ontology. It is a semantic index, is a reticular database, and provide spatial, geographical, and temporal reasoning among the several elements. The CKAN4City is used for discovery city entities and their relationship in the IoT device, IoT sensor, and also in the IoT apps. So you can control the hatches to the CKAN4City ontology and data, because on top of that there are the advanced Smart City APIs that you need to be authenticated and authorized to access. It can be federated and so on. You can access to the documentation using those links that are reported at the bottom of this slide. These are examples in the Tuscany, a lot of data, millions and millions. I think the world knowledge base in Tuscany is covering an area of 3.5 million. 3.5 million of inhabitants with about 40 million of tourists per year, and it is something like more than 1,500,000 street numbers and 16 different public transportation operators. To give you an idea of more than 21,000 bus stops and lines, and so is a huge amount of data. Amount of static data in which the dynamic data is also plugged as how the transport is moving, parking status, traffic sensor, hospitals, environmental sensor, bike sharing status, pollination, recharging stations, smart benches, irrigator, waste management, events, traffic events, entertainment events, fuel station, Wi-Fi status, status on mobile app, and tweets, and weather forecast. many other kind of sensor. The knowledge base is about something like 400 millions of tripods at present. So I am stopping here and passing the word to Michela Paolucci, that is talking about this how to upload the data set and point of interest via the IoT apps.